Hey, welcome to the garage. Come hang out with me today while I install this drive shaft. This is a new flange design from Gulfcoast for the ZL1. So it has a 14 millimeter hole, and it's also got the 12 millimeter hole for the SS guys. The tubing is 155 thousandths thick, and the SS version of this shaft is 125 thousandths thick. Now, this can be used on the SS, and the reason they go thicker is for the supercharged and turbo guys. So a little thicker, a little stronger shaft. So I was holding off buying this because they didn't have the 14 millimeter hole. I really didn't want to drill out the flanges they had before. It was just a circle here. And something else that they've done, which hasn't been mentioned, I don't know if you guys can see it. So you got this flat area here, and then right there you can see it, it's straight up. Now on the old flange they had this radius come around, and you would have a trouble with the hex bolt. Now the hex bolt, which is a 22 millimeter bolt head, fits perfect here, and you can get a socket on it. The problem is time you put a wrench on it, you're already running into this. So I'm gonna probably have to use a crow's foot on the torque wrench to torque this down, which is one of the issues I have. The other one, let me show you here. So this is the hardware they sent with it. You can see these nice 14 millimeter. The grade is similar to a grade 5. It's an 8.8 metric. I'm going to be buying 10.9. These are also called tap bolts because they're fully threaded. And I do not like putting threads into a flange where there should be a shoulder. Now I found a bolt online that I think is going to fit where this one goes. This is the report that I got with the drive shaft. So the green area is their spec for passing. The dot is actually where I was running. 4,500 RPM, and looks pretty good. Probably quite a bit better than stock. So one of the things they talked about is keeping heat away from the bonded areas of the shaft. 250 degrees is their maximum. Now I went underneath the car the other day after I'd been driving pretty hard and pulled it up on the rack while it was idling and took my heat gun and measured up in here on my current setup. So this one was about 216 degrees. The actual exhaust idling here was right around 200 degrees. And then down on the end here, kind of about the same. This was 180 and this was 200. So I'm not going to show you guys every detail on this just because it'd be too time consuming. But what I have to do is drop the exhaust first. So I have to take off these, and works best if you use like soapy water or Windex. There's a couple up here, and then because this is a ZL1, I've got MPP exhaust. I've got right there, that is a vacuum actuator to close the valve. So I have to pull those lines off so I don't yank them off. So these need to come off, those need to come off the vacuum line. And because I have the Hotchkiss chassis max here, I'm going to have to drop this, which is fine, and then loosen up these, and it should come out. Next is to loosen all this up, pull this off, get the heat shielding out of here so we can get to the drive shaft. We got it out in one piece, so gonna make sure it's marked so it stays indexed. So there you can see the difference in size, quite a bit bigger diameter. This is why the heat shielding is going to be a problem with this one. The heat shielding, I don't believe, is going back in. But let's weigh these real quick and see what the weight difference is. $26.4. $15.8. That's a 10.5 pound difference. That's pretty good. Carefully, we don't want to bang it into anything. Okay, it's on the pinions. Just line that up. Line the front one up. That's a good looking shaft, huh? Now in this car, the differential is held in to the cradle. The cradle is mounted to the body of the car. So the diff and the transmission, they shouldn't do this. Like in a car that has a straight axle. Because this is independent rear suspension, the axles move in relation to the body, not the differential. So if this is clearing now, it should always clear. So these are the bolts that they would have us use, which would be a smidgen short. These are 30 millimeter. So I'm gonna buy some 35s so they will come all the way out the back. You can see it's not coming through. I want that to come through, and I got plenty of room. It's not like it's gonna hit anything. I mean, it's not gonna run into that. So we're gonna buy a 35 millimeter bolt with a shoulder for this. Hopefully the shoulder's small enough. I think I found one. And then for this end, might be the same bolt. I might be able to go with the same bolt that I'm using over here, and actually put a nut on the back side. We'll have to do some math on that one. So this is a hardware that I bought for the new drive shaft. I got it from bellmetric.com. It is 13 millimeter, 1.50 pitch. These are 35 millimeter long. And these are 45 millimeter long. These are reduced OD washers, and the top locking flange nut. See, the hole's not quite round. So that's going to go with these, and these are going to go into the transmission side. And I did check the OD of these. This is the same OD as OEM. And then these are going to go on the differential side. I've run into a problem, and the problem exists even with their standard hardware they sent. So let me show you what I mean. So I mentioned to you guys before that they put in a 14 millimeter hole for ZL1, 12 millimeter hole for SS, Now if you put the drive shaft up using the pinion and it's just sitting there, and you go to take your 12mm bolt, and well, let's just say you want to put it in the 12mm hole because that's why it's there. Well, guess what? It won't go in. It won't go in because this is in the way. So I don't know how you're going to do that. This is a design problem. It could go in that one, but who wants a 12mm bolt in a 14mm hole? I realize that these are only clamping it together. It's piloted by the center, but I don't get this. I don't understand this at all. Okay, now this is the back and this is the diff side, so the bolts won't be this long on this end. So let's go to the other end and see. Are we going to have the problem here? Yeah. So I don't know. What are you supposed to do? Use that hole? This doesn't make sense. Alright, so these 35mm that I got from Bellmetric are going to work great. You can see it's got a little bit of a shoulder. I got the washer on it because I don't want to damage the aluminum. So let me show you if you're worried about the shoulder. You can see there's plenty of thread that's still going to be inside the flange, but the shoulder will give it some support. And it goes into each one of the holes, no problem. It clears this part. And if you can see that, but the washer and everything clears because they relieved the radius here. It's not a radius, they actually flattened it out, so everything will work. Won't be able to get a socket with the torque wrench, but you could put a crow's foot with the torque wrench, and that's what I plan on doing. So the Bellmetric hardware worked great on the differential end where it's required to thread into the yoke. The problem's with the other end. Let me show you. You can see that the 13mm and the 12mm that Gulfcoast supplies the same length, just this one has a shoulder for the flange. Now the problem I have is you can put it in this one fine because this will rotate out of the way, but what happens when you want to put it into this one? The head of the bolt gets in the way, and that doesn't work. So I got to figure something else out. One thing I'm going to do is I'm going to put my angle indicator on the yoke on both sides and see where we're at with the center line of the shaft on both the diff pinion and the transmission yoke. I want to make sure that our center lines are parallel or within spec. I've got the transmission mount off the car, and I went to put it back up there so I can measure pinion angle with the transmission resting as if it was torqued down. And I noticed that this is used for the V6 manual trans and the V8. And you'll notice this one's upside down because for the V8, front is this way. For the V6, front is this way. So there is a front and a back on this, of course. So I used the jack and the jack tray just to hold up underneath the transmission, so I could take this off to get that loop mount out. I've since put it back. I've tightened all these down just by hand, but you know, tight. And then also these nuts I tightened up as well to make sure everything's back into alignment. So I'm going to lower this jack so it'll settle, and then I'm going to put the angle finder on there. So this is the measurement I got on the angle finder when attached to the transmission. Was 87.5 on the downward side. It was 88.5 on the upward side. That's a difference of 1 degree. So if you were to kind of draw it out, you would see that they're parallel to within 1 degree, and that's within spec. So 0 would be great, but 1 degree is still very reasonable. So I know the car is going to be okay. I can go ahead and put the drive shaft on. Any oscillation in the drive line that's created from, I think the word is sinusoidal, but I'm not certain. Basically, the drive shaft goes faster and slower twice for every turn, and it's worse the more angle you get from this side of the U-joint than from this one. I'll post a link in the description to a guy's video on YouTube. It's very good, explains what I'm doing, rather than get into it here. But basically what I'm doing is the couple degrees that I'm out from center line on the shaft will get canceled when it goes into this U-joint, and so there shouldn't be any vibration. So that's why you measure it, to make sure you don't have to shim something. Now, it's probably good in my case because there isn't really a way to shim it. I may be able to shim the mount, maybe. You may be able to shim the cradle, I'm not sure. But it's not meant to be adjusted on the Camaro. And in this case, it doesn't have to be. So we're good to install it. Well, I started with this one, and to find out which way the center line was going on the diff and the transmission. So the diff was aiming up from center line, the transmission was aiming down. They're very close to parallel. This gauge and this one, there is about a half a degree, almost a degree difference in the reading. And these calibrations are very hard for me to see with my glasses. So I went and got this from Harbor Freight, and pretty simple. You just turn it on, you zero out the calibration, and then it's got magnets on one end. It's pretty hefty. It actually feels like a pretty good quality. And if I stick it on here, and I just kind of line it up best I can up and down. I mean, I don't think it has to be perfect. It says 87.1 degrees, so it's aiming up. 87.1 from 90. And then if I take it off and I run over to this side and put it on here, you guys can probably read that. I can't. 87.5. So there's a 0.4 degree difference between those two. Now one is aiming up, one is aiming down. But this thing has a 0.3 degree of error, a third of a degree. It says I'm within half a degree of parallel. What's important is the parallel of the center line. Because when we put our drive shaft in here, and we have these U-joints, the U-joint creating this bend of 3 degrees is going to make a sinusoidal vibration, a rotation in this shaft. So it's going to spin fast and slow, fast and slow. This is going to spin steady. Both of these are going to spin steady. This is going to want to kind of lope. And the only way it gets canceled is with another U-joint. And if they're parallel, they'll cancel it out perfectly if it's perfectly parallel. This is within a half a degree, plus or minus 0.3. We're still within basically a degree. So the diff and the transmission are within spec, and so having 2 U-joints on here should cancel any sinusoidal vibrations that could be caused. So this is the factory service manual for the Camaro. We're in the vibration diagnosis and correction. This is kind of a general guideline. It isn't specific just to this Camaro. So that's why there's some discrepancies in talking about single U-joint, 2U-joint. But that's good because the factory drive line is a single U-joint, and the drive line we're putting in, or drive shaft we're putting in, is a 2U joint. So you can see here that their drive shaft is at an angle, and the reason they're doing that, if you look down here, it says no U-joint working angle should be equal to 0. An angle of 0 degrees will cause premature U-joint wear due to the lack of rotation inside the bearings. So this is the one we're using here. Propeller systems containing 2 or 3 U-joints. The 2 U-joint angles each formed with the propeller shaft that contains 2 welded yokes are designed to cancel each other during operation. That's a sinusoidal effect that I was telling you about. These 2 working or canceling U-joint angles should be equal to each other within the specified range specified in this procedure, providing effective cancellation of the U-joints. Okay, so where is the range specified? Well, if we go over here, for prop systems with 2 or 3 U-joints, compare the difference between the working angles of the canceling U-joints to the following specification guidelines. Allowable range of difference between the canceling U-joint angles is 0.25 to 1 degree, which is what we had here. I realize this is straight, but bear with me here. So we took an 87.5 degree measurement off the transmission yoke and an 87.1, so that's 0.4 degrees. So we're within that 0.25 to 1 degree. There was a 0.3 error capability on my measuring tool, so I'm just going to call it that we're good there, and our specifications correct according to the service manual. So we can go ahead and start assembling the drive shaft onto the car. The original bolt that I got for the transmission end, 45 millimeters, had a little smaller shoulder than what I wanted. It really wanted to put enough shoulder in on the flange, so I ended up buying a longer bolt and cutting it down. You can see I get a little bit more shoulder to it, more of what I wanted. It would cover almost both flanges, leaving about 1 thread, but I am going to add a washer, so it'll be a couple threads inside the flange, but should work pretty good. It'll sit about there. So time you get the washer and the nut on, you'll have about maybe 2 threads sticking out. So we got the 60 millimeter bolts cut down to 45 millimeter or 1 3/4 and dressed the end up. We actually put a nut on first and then cut it, being careful not to overheat the bolt. We don't want to take the temper out of the bolt. So took it a little slow. If you have a way of cutting bolts this size without a cutoff saw, or maybe you have a hacksaw that runs coolant, even better. I don't have that. I'm just a little garage here, so I end up cutting it off with a with an angle grinder cutoff blade, and taking my time, letting it cool in between short little cuts, so I didn't overheat it. You'll know when you're getting it too hot because it'll start changing color, but that's still nice and gold. So we spun the nut off so we'd clean up the threads, and just chamfered it a little bit so so the new nut would start, and it starts on there great. So we're ready to put the drive shaft in. We're going to put a little bit of oil on the center pinion down here on the car on both ends, and then push it up in there.
So again, the only reason I'm taking the transmission mount off here is because I've got the loop here and I gotta take the loop off to be able to torque the nuts. Once it's torqued on this side, I'm gonna put all this back together. If you don't have a drive shaft loop, don't take this off. You don't need to. I'm just doing it because it's in my way. Aluminum on steel doesn't mix. This will help prevent galvanic corrosion. Just what I want to do. Up to you what you want to do. I'm going to put it on and then wipe it off so it's just a film. I don't need it to look like icing on a cake. There you go. Very thin coating, just enough to make it silver. Basically, I'm going to take the shaft, I'm going to guide it into the pilot, I'm going to compress the slip joint until I can clear the pilot on the diff and release it into both pilots and it'll hold. So being careful not to bump anything here. Going up, I don't want to scratch the carbon fiber. Okay, so that end is in. I'm going to compress the slip joint and bring the back side up. You can see in there the pilot in the back here. In there. So that is touching. I just rotate that to line the hole up. We're going to have to do this one. We'll kind of line this up first. And then we can spin this one because we're in neutral. So we'll set these bolts first. At least get them in there. These ones here, these are the 30mm. It is tight. But they do fit. We're going to leave them all a little loose for now. I'll be pulling them back out to put blue Loctite on before I torque them. But I do want to get these started just to make sure I'm not going to have any problems getting the bolt in. And it doesn't appear so. I got them all started. They're all clearing the yoke. And now we're going to start on this one. This one's going to be a pain because the bolts are only going to go in from this side. I'm not going to be able to put the bolt in down here because this is in the way, or up here. A lot of the stuff here is just in the way. So what should I do? So either way, I need to move the car in order to line this dumb thing up. Alright, so I took out the rear bolts so I can get the fronts in, because it would be easier to get the rear in because I can put those bolts in just about anywhere. This one is only going to allow me to put it up in a certain spot because I got to bring the bolt in this way. Remember, I can't bring it this way because I'm hitting the yoke. So, and bring it up, put it through, washer, and my nut. So these are 22mm, so 7/8 will work. which is what I'm going to use. So I'm using Loctite 243, which is medium strength. On top of having the lock nut. I don't want this thing coming out, ever. So again, in the service manual, under propeller shaft. So these are the specs depending what differential axle you have. So the ZL1 is the 250. The 218 is the Z28, and I believe the SS, and I believe the 195 is for the V6 versions. I'm not certain about that one. If you don't know what you have, this is what it'll look like. Explains what all that means. So for the 250 millimeter rear end, transmission side, it's going to be 100 foot-pounds or 135 newton meters. I'm going to torque it to that. I know the bolts can take a lot more, but I'm not going to take it past what they're recommending in the book. What you do is up to you. This is the rear end for the 250 millimeter ZL1. 118 foot-pounds at the rear end. 160 newton meters. So the bolts I have, I believe 147 foot-pounds is nominal torque rating for a 14 millimeter 10.9 grade. It can go even higher than that depending on certain things. But I'm going to stick with the book because I don't want to distort or harm the transmission yoke and the rear end yoke. I'm going to be using a crow's foot. Tighten that, torque it with the 7/8 box end on the back. I'm going to start out at 65 foot-pounds. Go to the next one. Now I'm going to run it up to 100. If you ever go to use one of these, be sure that you're at a 90 degree with the torque wrench like that. If it's up here, it changes the length and changes the calibration. Mathematically, you can figure it out if you had to, but not really intended to be used that way. I'm wanting to make sure that my wrench is not going to bottom out on that. I'm using the car to hold it. Okay, well, that didn't even feel like I moved it. So I must have been right on the verge of clicking that in. Alright, that's good. And I'm verifying that I'm not cramming the crow's foot. I'm not cramming the crow's foot into the yoke. Okay. So all three of those are torqued. I'm just going to check this one again. Looks good. Okay, so if you guys want to get really technical, you can weigh your hardware. This is in grams. 64.3. 64.3. 64.8. So you could shave some off the top of the head until you got down to where you wanted. I don't know if it's going to make a difference. I mean, it is weight that's spinning, but I don't know. I don't know how critical that is. I would say it's better to keep them all the same weight than not to. Don't forget the washers. .8, 4.7, 4.8. So that one is a little heavy. But if you wanted to do that, especially when you cut your bolt to length, if your bolt is a little longer or shorter, it's going to change its weight. It is rotating, of course, with the drive shaft, and of course they balance the drive shaft. Well, in case you guys took this off, these tighten up to 43 foot-pounds. These four, and also the two nuts up here. Those two nuts don't look like they would go to that much, but that's what the book says. Yes, it does. Alright, well, I got the bolts tight using the crow's foot. Now, in order to rotate this around so I could get the torque wrench line up, I would put the car in neutral and move it so where the bolt was in alignment. I'd put a wheel chock, also throw the car in gear with an e-brake, and then torque it. And then I would just repeat it for the other two. So I didn't record it because it was a little frustrating. The crow's foot, it worked. I got them to 118 foot-pounds, like what the spec is. It was a little tight. Having the car in gear and not letting the car move back and forth definitely got it to torque a lot easier. So put it in gear, put the e-brake on, and that'll help keep this from rotating so you can get these torqued. So it's installed. I just need to put the drive shaft loop in, get the exhaust on. Of course I'm gonna put all that back together, but should be done. Get all this together and we'll see how it goes. I'm wrapping my exhaust with DEI titanium wrap using stainless steel clamps. There are better clamps than this. These are cheap actually. Stainless steel bands, stainless steel housing, but the screw is still zinc. It will rust. You can tell the real stainless steel through and through because they're about $5 a clamp. These were like $2 at O'Reilly's. So the amount that I used on here, that's 15 feet. 25 would have worked better. And I've got 150-foot roll cut in half. And I went from the H pipe down to here, as you can see. Now that black line right there, that's going to be in the back of the yoke. So I'm actually even further back. But you want to start here and wrap this way so that it overlaps like a shingle. So the air coming under the car will skip off of these. You don't want dirt and water and junk underneath this. I don't know how well this will last. I don't even know how well it'll work. I'm really looking to just block radiant heat from the epoxy on the ends. So you can watch me wrap this. I have another video when I did my headers. You can check that out. This isn't a requirement. It's just something I want to do. funny noises like the last time I messed with the driveline when I don't know if I ever put that on YouTube or not, but I was putting my drive shaft loop on, and I didn't quite get it angled right, and it was hitting part of the drive shaft. Anyway, I went home, loosened it up, straightened it out, and it was fine. But so I don't notice any weird noises. I don't notice any vibrations. I've only had it up to 60, so there's not really any good places around my house to do 100 miles an hour. I mean, they're little country roads, and they're not very flat. So I am going to do a little pull over here, and I gave it a little bit back there, and it feels different. I don't want to say it feels like it accelerates more, because I'm on 93 right now, and well, 93 doesn't accelerate like E85, but it felt more connected, like there was less give, I guess. So well, that felt good. That was all the way up to I believe 6,000. No vibration, and yeah, felt pretty good. I think it's gonna do all right. So we'll have to get a better feel when I can get out on the open highway and get a little more speed. So I did want to show you guys, I used my digital multimeter with this thermocouple, and I wanted to check the temperature where the drive shaft yoke, where the bond is that they make, because they said they don't want it any higher than 250 degrees. So I ran the car. You just saw the little run I did, and brought it in on the lift. I didn't bother to record it because you wouldn't be able to hear me anyway, but I just held this right next to the drive shaft, right above the exhaust pipes on both ends, and only got to about 200 while sitting idling. Even with the heat wrap on it, still gets warm. I mean, it's not an insulator, but it does protect it from radiant heat. We're gonna call it done. Thanks for coming to the garage, and like and subscribe, hit the bell, and we'll notify you when there's another video. Take care.